Hello and welcome to 20 years of streaming in 20 minutes. Your speakers today will be Yuri Reznik, Technology Fellow, Head of Research at Breitkopf, and Christian Timmerer, Associated Professor at University of Klagenfurt and CIO and Head of Research and Standardization at Bitmoving. The talk will have two parts. In the first part, I'll talk about early designs of streaming systems, examples of such systems appearing in early 90s, in fact, and their evolution still about 2008 when HTTP began to emerge as a much simpler foundation for designing of such systems. And in part two, Christian will talk about what happened with streaming beyond 2008 and present standards such as Dash, HLS, CMAF, and where things are moving beyond. This being overall objective, let us now first try to take a look back at overall timeline and try to see where streaming fits on this grander scale of things. And first things that we notice, of course, it's a very new development. It appeared after television systems were already out. Radio was, of course, decades before distribution by using physical media such as VHS tapes and discs was known and used broadly. And what streaming brought is really convenience and reach to a new audience, and that was a population of users of PCs connected over internet. And if we look back, we notice that probably first successful example of such system was MBON. It was a connection of computers operated by universities in the US and Europe, forming virtual multicast networks of sort, and it was used for streaming, sending files, and for distributing media. For example, 1994 concert of Rolling Stones was successfully streamed over this network, probably first major online event streamed, 1994. Big milestone. In 1995, Real Audio, built by a company called Progressive Network in Seattle, was another milestone. It was a system that was reaching actually pretty much any PC connected over internet, subject to having a particular software installed called Real Audio Player. This technology, of course, was using UDP as main transport protocol for sending real-time audio data, and TCP and HTTP and so-called clocking regime were used as backup options to reach behind firewalls, but it was working, and at launch it used to stream several high-profile events. For example, 1995 game between Seattle Mariners and New York Yankees was watched by thousands of viewers over the internet, and it got noticed. It made the headlines, become wildly successful. Progressive Networks was not the only technology, the only company building this kind of technologies. Of course, there were many others. VideoNet, Viva, Microsoft with NetShow initially, which later became Windows Media, VXstream, Zing, Blaze. Those are examples of companies that existed those early days, and it was highly competitive. There were multiple acquisitions and consolidations that went over. So by about 1998, only Real Networks and Microsoft realistically remained, joined by Apple in 1999. Interestingly enough, what also happened around same decade is ABR streaming system was introduced, the Real System G2, 1998. It was well over a decade before first HTTP-based streaming systems were invented. Before I started talking about ABR streaming, let me also note a couple important innovations made those days. First, I think most important was introduction of pre-roll delay. How come it was innovation? Well, because before it didn't exist. Some early systems just tried to use video conferencing type of stacks for streaming, and they really worked poorly. And with this pre-roll delay, it was possible to kill multiple rabbits with one bullet, so to speak. It was used for amortization of network fluctuations. It was also used to reorder UDP packets which were arriving, of course, out of order. It was also used to facilitate limited retransmission attempts. Why limited? Because you couldn't those days do full retransmissions. TCP worked very, very poorly. And it was importantly used also for implementing a form of multiple description coding. So what Real Audio did is it packetized audio frames in interleaved fashion in UDP packets. So the audio frames were about 20 millisecond long, and if UDP packet was lost, the effect was not a loss of continuous chunk of audio, which of course would be noticeable and annoying, but instead what was lost is a spread array of tiny frames that were missing, and those frames were very easy to conceal. We used bidirectional prediction and crossfading, and it worked remarkably well. And even pretty heavy packet losses, like 5–10%, were manageable with this type of technology. So for audio, I think those set of technology address the issue, but with delivering of videos and other data that required much higher bit rates and more aggressive utilization of networks, well, other means were necessary. And SureStream was probably first adaptive bitrate streaming system that was successfully developed and deployed. So encoder was producing multiple streams encoded multiple bitrates, multiplexed in so-called SureStream container. Then server was doing sub-selections of the stream, sending this to client, and it was well deployed. And another remarkable success story, by the way, it was all published, patented. There are a few references here. And if we look internally, it actually was working very similarly to ABR streaming that exists today. The main differences were that there was no CDNs. The transmission was done over public IP. UDP-based transports were preferred. RTSP was used for session control. The server was sending sub-selected streams at packet level, and it was also doing a few other things. It was doing retransmissions if client was requesting them. It was also mixing in FEC packets again if that was appropriate. And but the switch decision logic was in most cases driven by client. And it worked. Of course, there were several challenges with this, but they were quite successfully addressed. And in fact, there were even standards developed to describe how such systems should be done, developed in an interoperable way. There was RTSP protocol designed by ITF. There was ISMA, a set of specifications prescribing particular flavor, for example, of ISO-based media file format with hint tracks to be used for this, and full stack of codecs, everything with conformance specs, with conformance streams. It was a well-developed suite of standards. And likewise, 3GPP and 3GPP2 developed their own stacks of specifications to support this type of operation. So it was all well developed. In fact, there were Emmy Awards, 4 of them, given for invention of RTP, RTSP based streaming. Real Networks, Microsoft, Apple, and Adobe got this, and it worked well, and all of a sudden all died out. Why did this happen? Well, networks have improved, and that probably was most significant effect. When capacity goes up by a factor of 100, latency is going down, packet loss is going to 1%, you could start using progressive download, and that begin to look satisfactory for many applications. CDNs become ubiquitous. RTSP streamings were complex. If there was any major complaint about it, dealing with error concealment, packet losses, it was a hassle. But other than that, they were working and quite well. But all this complexity turned out was unnecessary once networks have improved. And so modern days we see much simpler designs being dominant. HTTP-based streaming. So on this note, let me pass control to Christian, who will talk about HTTP streaming and modern era and evolutions of the standards in the future. Thank you.
Thank you, Yuri, and welcome to the second part, which is about video streaming over HTTP, its different flavors, how that all evolved to Dash, HLS, and CMAF. And finally, I want to give a brief summary. While it is true that many standards lead to competition, which is usually good for innovation, but on the other hand, we need to be very careful not ending up in the situation like it is shown here, where many different competing standards make things even worse and possibly leading to much fragmentation. So let's see how that evolved in the case of video delivery over HTTP, where it started in the early days with progressive download, which enables basic streaming experience that enables the playback while still downloading. Moving over to pseudo streaming, it enables the user a bit of interactivity. Also, the server could change the transmission based on different factors. It has been then further developed to chunked streaming, where the content is divided into short duration chunks, specifically designed for live streaming, but also ad insertion. And then in the adaptive streaming, the final step of the evolution so far is where you have multiple versions of the content, which allows for dynamic adaptation according to the context conditions. Progressive download, as it started in the early days, opens a HTTP request to the server for the video file, and then in the single HTTP response, you get the content delivered progressively to the client, which enables a playback start once a couple of information is available on the client. Also, typically in these scenarios, in the beginning, the client try to download everything as fast as possible, leading to waste if, for example, the user clicks away and stops watching, and also interactivity in terms of seeking for the content was only possible throughout the fetched content. In that scenario, also, people did some analytical performance studies, and they came up with the conclusions that you get a good streaming performance when the achievable TCP throughput is roughly twice the media bitrate. On the other hand, then streaming is cooler, it sounds also cooler, and it's also more viewer friendly because the startup time could be possibly reduced. Also, people realize that not downloading too much ahead in case the user clicks away, which results in less waste, and also it was possible to seek anywhere in the entire content. And then also people try to mimic what has been done in RTSP or RTP-based style streaming via HTTP by sending reports back to the server to adaptively change the quality being transmitted, still over progressive download. But then sooner or later, people looked into the early days of HTTP adaptive streaming. It all started roughly around 2008, 2009. Some standards committee jumped on the train and started working on or towards standards in this area. One of them on the left side was MPEG, trying to address this as part of their MPEG Modern Transport or MMT initiative with a couple of different requirements. One of them also content adaptation to different networks. And later on, this was split into two tracks. One still called MMT, but then renamed to MPEG Media Transport. And the other, at this point in time, was called HTTP Streaming of MPEG Media. At the same time, the first draft of HTTP live streaming, HLS, became available, which introduced variants to allow clients to switch between encodings dynamically. About 1 year later, MPEG was ready to issue a CFP on HTTP streaming of MPEG Media. The responses got evaluated in July 2010, resulting in the first working draft of dynamic adaptive streaming over HTTP or Dash. And then the first milestone, the committee draft, was then issued in October already, and then we also saw some first implementations, including GPEG and VLC. And then roughly about 1 year later, Dash was ratified, which means the final draft international standard, or FDIS, became available. And at the same time, the Dash Promoters Group was formed to go even beyond what MPEG did with the standard itself in order to make it deployable by the industry. And then finally, in April 2012, the first edition of Dash was published by ISO, and at the same time we also saw first web JavaScript-based clients becoming available. The Dash Promoters Group was turned into an industry forum, and then also releasing its reference software as a JavaScript-based client, which is now referred to as Dash.js. We all know roughly how it works. You have a HTTP server where you put the content in multiple versions that is chunked into smaller segments, and then more or less you give the client a manifest that, based on the client's conditions, for example in terms of the bandwidth, can fetch the segments individually and can dynamically adapt to the changing user environment. So everything, the intelligence, is on the client. It's not defined by any standard and is subject to research and development, which then resulted in multiple bitrate adaptation schemes to become available. They can be roughly clustered in client-based adaptation, as you can see, which covers the majority of the approaches due to the nature of HTTP-based streaming, but there are also server-based, network-assisted, and hybrid adaptation schemes available. The adaptation is possible also thanks to the data model, and here the Dash data model is presented, comprising multiple periods over time that can be further then divided into adaptation sets, which allow component or track selection, and then each adaptation set can be realized in multiple representations, which are the different versions that then the client can request based on HTTP URL that can be constructed in various different ways, and the template mechanism is just shown here as an example. The current status of MPEG Dash is that the amendment first to the 4th edition has been finalized, which is again a interesting milestone, as it adds CMAF support for Dash, trying to harmonize the two formats also in the Dash specification, which then will result in the 5th edition to be available in 2021. Talking about CMAF, defines a media format only. It's one component out of 3 components in the media delivery space, and the manifest and the delivery is not within the scope. And one important aspect that CMAF adds to the media delivery environment is the concept of chunks, so that you can divide segments into smaller chunks, which then allows for low latency deployments, and we see different flavors of that. CMAF uses the ISO-based media file format and the common encryption, and thus harmonizes the 2 worlds of Dash and HLS to a common media format, which is based on ISO-based media file format. Of course, the way on how you do the streaming, on how the logic is not defined, and that's why we also see like different variations, and one possibility is mentioned here. In order to conclude and in order to summarize, we all started with RTP-based streaming or UDP-based streaming in the beginning. Later on, Move Networks was among the first who brought up HTTP streaming approaches, survived in Slinkbox, which is now discontinued. Legacy formats are Smooth Streaming, Flash, and HTTP Dynamic Streaming. And as you can see here on the video developer survey, that is listed here, is that these formats are really kind of fading out, but the state of the art is clearly HLS and MPEG Dash, but you also see the rise of CMAF in this context, especially when you look at the number of what should be used or planned to be used in the next 12 months. What is next? We could even look at the transport layer, and here Quick is rising and gaining momentum, but Quick is based on UDP. So the question is that the history repeats again. So we look again into UDP-based streaming for the next decade. We will see in the future. Thank you very much for your attention on behalf of Yuri and myself.